Welcome to the last week of developing web applications. We will focus some more on MySQL as well as figure out how to complete your final project. You've made it this far in the journey. It's time to finish off strong. As touched on by now constantly, all previous work can be reviewed on the web space. So some basics. A new database is creating using the code create database name. You saw this previously when we created schemas. Select is the function which allows you to choose something in MySQL. We'll see later on the select from where. The where function is also needed when using the select function to see where your request is. The from function relates to the select and where function. As mentioned, often seen, select from where. A join type is based on join condition. You can join tables or schemas together based on your needs. So here is how you would create a contact table with SQL code. So we created the table called contact. We create a attribute or field called contact ID, which is an int. It is not null, so it has to have information inside it, and it is our primary key, so it is important. Within this contact ID, we have information associated with the contact ID. Our first name, which is set at a limit of 30 characters. Our last name, again, 30 character limit. Address, city, state, and zip code, all set at 30 character limits. Most commonly, a zip code might be set at 10 character limits. You might have your common 5 integer zip code with a dash, and then the 4 less common numbers specific to a zip code. So here is our select from where. We select from an attribute list. What information do we want from our specific schema or table? So for example, in the previous example, our attribute would be contact ID. And from, we need to select what our table is. So in the previous example, our table would be contact. And where? Under what condition or circumstances are we trying to find this? So again, the attribute list is a list of potential attributes to choose from. The table is the list of potential tables to choose from. And the condition identifies the tuples to be retrieved by the query. Tuples is a commonly used term within database theory. It simply means rows. Or in Access, these would be the same as records. So within a select from where, you can have specific conditions. You may have logical comparison operators, equals, greater than or equals to, etc., etc. You may have projection attributes, where the attributes are values that are to be retrieved. You don't have them yet, so you're in essence guessing. There's also selection condition with a Boolean condition, which is a true or false. So here is another example. You're going to select first name, employee.name, and address from the employee table and the department table. You'll notice here, employee.name is giving it away that that specific piece is from the employee table. Where? Well, we want to find where the department name is research. So anyone within the research department will be featured in this query, and that their department number has to equal their employee department number, which means whatever their department number is labeled as in the employee table matches up in the department table, so you do not get multiple results for the same person. There are 3 common commands when modifying a database: insert, delete, and update. Insert typically inserts a new tuple or row into a relation or table. Update may update any number of tuples within a table that need to be updated. Delete as well. You can delete any number of specific tuples within a table based on what satisfies your condition, whatever you put your specific SQL commands as. There are also aggregate functions within SQL that are used to summarize information from multiple tuples or row into just a single row summary. The most common are count, sum, max, min, and average. You will have seen this within Access using the totals row. You can also group, create subgroups of rows before summarizing them. You may have seen this using group by within Access. You can also use the having clause to select entire groups. You can only use one or the other though, the select or having, not both. Then there are also assertions and triggers. You use the create assertion command to specify additional types of constraints outside scope of built-in relational model constraints. Consider these similar to your assumptions. You can also use the create trigger command. These specify automatic actions that database system will perform when certain events and conditions occur. For example, in a lot of cases where an entire company is utilizing the same database, you will have a trigger created where it timestamps all activity when someone is logged into a database. This is helpful when you determine who made certain updates to a database. You can go through and reference to see the information timestamped. Here is a visual of how an assertion works. So here we're checking to see if we have a salary constraint. We check to see if it does not exist within our employee salary being greater than management salary. They don't want this to happen, so they need to check if it exists or not. Here is a trigger visual. We create a trigger salary violation. So anytime that a new salary is greater than the salary of a supervisor, this new supervisor is informed that the new salary is greater than the supervisor. Previously, you were given some information on basic command prompts within MySQL. Here are some more. Once you have the prompt MySQL with the greater than symbol, you're ready for a new command. As you see these certain prompts, you have the specific meanings associated with them. So what is querying? Well, you're looking to see if something exists. So here, define all loan number for loans made at the Perry Ridge branch with loan amounts greater than $1,100. We select loan number, our attribute, from loan, our table, where branch name, our attribute, equals Perry Ridge. That is our branch. And amount greater than 1,100. If both of these situations are not true, we don't get that result. Here, we're asked to determine loan number of the loans with loan amounts between 1,000 and 1,500. So here, instead of searching for the branch name, we're just looking where amounts between 1,000 and 1,500. It will only return loan numbers of loans in the amounts between those two numbers. With respect to joins, join operations take two relations or table and return as a result another relation or table. Basically, this eliminates multiple information of the same record. Instead of having information on one person that is specific to two different tables, it just pulls everything together and puts it into one tuple or row. With a join condition, that defines which rows in the two tables match and what attributes are present in the result of the join. As previously mentioned, you're not going to have repetitive data. Join type defines how rows in each table do not match any row in the other relation and how those specific join conditions are treated. Here's a visual of certain types of joins. You may have join types such as inner join, left outer join, right outer join, full outer join. And you may have join conditions like a natural on a specific predicate or table using the attributes associated. So here we build assignment 15. You're asked to increase all accounts with balances over $700 by 6%, and all other accounts receive an increase of 5%. So we update account. We assume our information is all within the account. We set our balance to case. That is our current case, our situation. And we do when balance less than or equal to 700, then balance times 1.05. This is our current balance plus the 5% increase. Else, balance times 1.06. That means if it's greater than or equal to 700, we get the 6%. And then we use our end statement to end our command. With respect to the final project, use the information provided on the web space. The home page provided to you is similar to what you would create for your own home page. However, you want to list specific information about yourself, so when individuals visit your specific web page, they know a little bit about you. The My Work page should look almost exactly similar to the work page I have, but you will list or link your work instead of mine. The contact page you create should look like mine, but you can add your name or other info to the header if you want. You might also want to use your .css file to set text color and background color, or you might even want to create your own .css file or embed it within your web pages with other specific colors used. With respect to the extra credit, if you would like to complete the additional form, reach out to me directly for assistance, as not everyone may want to do this. Congratulations, you survived developing web applications this semester, and you now have a visual online to show off your work.